All right, dudes. You've made it to part 3. It's time for your ascension. We are about to enter trinomial quadratics. We have 3 piles, 3 terms that we cannot combine: an x squared, an x, and a no x's. This is important because we have this. GCF is not going to work. Okay? I talked with you about part 2, about how part 2 is going to sneaky be the hardest because we're going to be so locked in on this number that when it's missing, we're going to get stuck. But now that it's here, for trinomial, I like to take the first number times the last number. The good news is this number is pretty much always going to be 1. Okay, if you get a number that's different here, it's your teacher trying to be a bit mean and give you some hard questions, maybe a bonus. 1 times 2 is 2. It's a positive 2, which means we need 2 positives or 2 negatives. Our only options are 1 and 2. This is very easy. X plus 2, x plus 1 equals 0. Because we are equal to 0, we are allowed to take these one at a time. X equals negative 2, x equals negative 1. X squared, we expect 2 answers. Over here, we have equals 12. I told you that I would warn you about this, so let me show you this, okay? Students will do this. They will say, GCF? They'll take out an x. Oh shoot, shouldn't have wrote that. That's okay, fixed it, sort of. They'll take out an x, and then they'll say x equals 12, and x plus 1 equals 12, and this is a crime. This is really bad, okay? You have to have equals 0. You have to have equals 0. So, the correct way is to subtract that x squared over there. Sorry, subtract. I'm trying to write and talk. Don't look at the time. It's pretty late. I'm going to get x plus 4, x minus 3 is equal to 0. It is equal to 0. X equals negative 4, x equals 3. I get 2 answers. Okay, here we go. We're in the big leagues. Sine squared, x plus 3 sine, x plus 2 equals 0. Now this is exactly the same question right above it, okay? Remember, if all of this sine squared scares you, you can just make it an x squared. If all of this sine scares you, you can just make it an x. And so sneaky, you're looking at x squared plus 3x plus 2. It's the same question we just did, right? First times last is positive 2 plus plus minus minus 1, 2. X plus 2, x plus 1 equals 0. X equals, sloppy. X equals negative 2, x equals negative 1. There's our 2 answers, but really we want sine x equals negative 2 and sine x equals negative 1. Okay, now let's do that same thing. Oh my god, it is too late for me to be doing this. Let's do that same thing. That is so embarrassing. Oh my god, cringe. We've got sine squared x plus 3 sine x plus 2 equals 0. It's just x squared. I'm not even looking at the signs, right? I'm totally ignoring the signs. I'm only looking at the numbers. 1 times 2 adds to make 3. That's going to be sine x plus 2. That's going to be sine x plus 1 equals 0. Sine x equals negative 2. Sine x equals negative 1. Now, when we get this far, this is something that totally might happen. Okay, we talked before about how we expect to find 4 answers when we're doing these sine squared. Here's my issue. When is sine equal to -2? If I ask my calculator, second sine -2, error, domain. The value entered, it's not working. Okay. So, remember our sine graph. It goes up to 1 and it goes down to -1. This right here is no good. We're getting no answers from that. This piece over here, where is sine -1? That is a good answer. Sine does equal to -1. I can use my unit circle. I can use my graph. X equals 270 degrees. And that's it. So for this question, we got only one answer. We were kind of expecting 4, but we had a whole dud. This was a quadrantal. We ended up with just 1. I'm going to do this question. First of all, this is a problem. What is the 4 doing? I need a 0. Move it. Cosine squared x plus 3 cosine squared x minus 4 equals 0. A little bit dumb how I wrote that, because normally this line should be where the equal sign is, but whatever. You know, I did a little -4 and a -4. Now I'm noticing that for this question, I've got cosine squared and cosine squared. So I'm thinking, is this some kind of trick? Right? Those are like terms. That's 1 cosine squared plus 3 cosine squared. That's actually 4 cosine squared x minus 4 equals 0. Well, wait a second. I know I just moved this 4 over here, but now I only have one pile of cosines. This is not a trinomial where I have 3 piles. This is not a GCF where I have 2 different piles of cosine. I only have 1. My fingers look ridiculous under this camera, but maybe I'm just being so weirdly critical this late. I'm actually going to go ahead and add this 4 back to the other side. Cosine squared x equals 4. And then I'm going to divide by 4. Cosine squared x equals 1. And then I'm going to square root both sides. Cosine x equals plus or minus 1. And this reminds me of that very first sheet of paper. Where is cosine x equal to 1? Where is cosine x equal to -1? Maybe I think about my unit circle. Maybe I think about the graph of cosine. +1 at 0 and 360. -1 at 180. But I don't get to count 360. And so my answers are x equals 0 and x equals 180. A little bit funky how we had a cosine squared there. Looks like we do have a sneaky little question on the back here. It says use your calculator to solve. So that always gives me a hint that things are not going to be on the unit circle. And I do see that, like I said, your teacher's only going to give you a number out front if they're trying to be a little annoying. So here we are. Well, I'm going to go ahead and multiply that to get -3. That means I need 2 different signs, a 1 and a 3. In order to do that, I need to add it together to make a -1. I don't think it works. Right? I don't think it works. There's no way to use a 1 and a 3 to add up to make -1 in the middle. I don't think I can factor this. It does say use your calculator. So what are we going to do? What are we going to do? The calculator does not do a very good job solving for x. Okay? But it is a you know what I'm doing? I'm going to go ahead and graph this. 3 cosine of x Now, how do I make it cosine squared? I'm going to have to close the parentheses and then put a squared. Okay, that will work. Now, if I do it like this, totally different, we're doomed. 3 cosine x parentheses squared minus cosine x minus 1. You see how this looks? I don't really like this. I want to go back. Go ahead and make sure I had a parentheses in there. Close up all my parentheses on all my cosines. Okay. 3 cosine squared, negative cosine x, minus 1, minus 1. And I'm also going to look at my window here pretty quick. Okay. So my window is what I'm going to see when I look at the graph. And this might be a little advanced here. My x value needs to be between 0 and 360. So you know what? I'm going to do negative 10, 370. I'm going to give myself that 0 to 360 plus a little extra. Okay. It says I'm going to look where this is equal to 0. So I want to make sure that for my y values, I'm looking, let's just do negative 3 to 3. I want to make sure that 0 is showing, and really I'm looking for where. And then let's say graph and let's see what happens. Okay. I definitely see one value where it's equal to 0, 2 values, 3 values, 4 values. So remember, this is 0 here. 1, 2, 3, 4. And over here, this is, too big. That's 360, 370. I'm only looking between 0 and 360. And if I want to find these intersects, these x-intercepts, I can do second. So you can press the second button here. So you see up in the top, it gives me that arrow. And then I can do calculate, this trace button. I can calculate the intersect. Now I don't really want to calculate the intersect. Hold up. I want to find the 0. That's what I want. Now if you've never done this before, it says left bound. That means I need to put this on the left side, right bound, on the right side. You see how that's made windows around the intercept that I want? And then the third option says guess. This one doesn't matter. Enter. Cool. There it is. It told it to me. I got x equals 39.86. I'll just do 40. All right, let's find the other one. Second, calculate 0. It says left bound. So I'm going to zoom in here. I'm going to go left, right, guess. You really don't have to guess. It tells me a new 0 is 115.7. Maybe I'll do 116. Let's do it again. Second trace 0, left bound, right bound. So let's do, maybe zoom in a little more. Left, right, guess. There it is, 244. And let's do one more. Second, calculate 0, left, right, guess. I just pressed enter because the guess literally doesn't matter. 320.1, x equals 320. There's my 4 answers. Now, here's what we figured out. With a calculator, we can solve these questions, okay? If you took Algebra 1 and you learned how to pass the SOL test and your teacher used to teach you a long time ago, just type it into Desmos and look where it crosses the x-axis, right? I don't know if you remember that. You guys were doing COVID algebra. You guys get it. It's the same thing, guys. Type it in, See where it crosses the x-axis. Okay? I'll be honest, this is rare. Okay? I know we just spent like 5 minutes doing this. This is a rare thing. You're not likely to see this. What you're more likely to see is a question that looks something like, what about cosine squared x plus 2 cosine x plus 1 equals 0, right? This is much more likely. You're going to try to factor this. 1 times 1 is 1, plus plus minus minus, 1, 1. How do we make 2? Cosine x plus 1, cosine x plus 1, cosine x plus 1 equals 0, cosine x plus 1 equals 0, cosine x equals negative 1, cosine x equals negative 1. These are the same thing, which means I'm going to get the same answers twice. One is cosine negative 1. That's at x equals 180. And then, of course, that's x equals 180. And this one here, kind of useless, right? I've already got it. So much more likely, you're just going to do a normal question. But if you can't factor it, it's there. Now, honestly, I'm kind of annoyed with myself that I'm even still talking, but can we use the calculator to solve this one even though it's pretty easy? Cosine x, close it, squared, plus 2 cosine x, close it, plus 1, second, trace, 0. Here it comes. Ooh. We get 2 different answers? Oh. Maybe just one. Left bound, right bound, enter. 180, right? Exactly like we thought. 180. That looks a little strange on the graph here. Let's zoom in a little bit. Negative 0.5, 0.5. Why does it look like that? I don't know if you can tell on your screen, but it looks like it goes below. Alright, let's do it one more time. Negative 0.01, positive 0.01. Alright, I got a problem with these calculators. Stupid. Alright, well, we're done. I've been yapping now for too long. GG's.